All right, today we're diving into an idea that is so radical it pretty much turns physics completely on its head. It's called the Holographic Alaya Field Framework, or HAF for short. And you're not going to believe what it suggests, that reality isn't made of things at all, but from the very act of seeing those things. So let's jump in, and I want you to think of this as a kind of detective story. For almost 100 years, physicists have been stumped by some major mysteries. It's like a cold case that just won't crack. But what if they've all been overlooking one single fundamental clue, an assumption so basic we never thought to question it until now? So, let's go to the crime scene. We've got two huge, unsolved cases in physics that have been sitting there for nearly a century. And, on the surface, they look like they have absolutely nothing to do with each other. Okay, on one hand, you've got gravity. It's the odd one out, right? The rebel of the fundamental forces. It just refuses to get along with the others. And then, on the other hand, you have the quantum measurement problem. How does that bizarre, fuzzy world of quantum possibilities suddenly just snap into the one solid reality we see every time we open our eyes? This is where the HAFF framework comes in with a bold new lead for our investigation. It asks a pretty profound question. What if these aren't two different mysteries at all? What if they're just different symptoms of the same single mistake we've been making in our thinking all along?
So what is this hidden assumption? Well, it's something so fundamental, so baked into how we see the world, that we barely even notice it's there.
We just assume the universe is like a giant Lego set, It comes with a box full of basic pieces, electrons, photons, quarks, and the laws of physics are just the instruction booklet telling us how to click them all together. We think reality is built from these separate pre-existing parts.
But HAFF just throws that whole idea right out the window. It says no. The universe isn't a collection of parts. At its most fundamental level, it's a single, unbroken ocean of potential. And in this view, the parts we see don't actually come first. And this is a complete 180, a total flip. The standard view says you start with the parts, and how they interact creates reality. But HAFF says you start with the rules of observation, the rules of what's possible to see, and those rules are what carve out what we call parts from that seamless whole. In other words, things don't create reality. The act of observing reality creates the things. So let's follow this train of thought. If observation is what really matters, if it comes first, what on earth does that mean for the very fabric of the universe? What does it mean for space-time and for gravity? Okay, this is a massive leap in thinking. In the HAFF view, space-time isn't the box that reality happens inside of. It's more like a network diagram. It's a map that just shows how all the different possible observations relate to each other. The geometry of space is literally made out of the geometry of information. And this gives us a really fascinating reason for why gravity is so weird. Think about it. Other forces, like electromagnetism, they're like actors moving around on a fixed stage. But gravity isn't an actor on the stage. Gravity is the stage itself, bending and changing shape. It's describing the evolution of the whole map of reality. The source material gives us the perfect analogy here. Changing the other forces is like drawing a new road on a map that already exists. But changing gravity? That's like changing the entire projection of the map itself. Switching from a flat Mercator map to a round globe. It changes all the fundamental rules of distance and shape underneath.
So if observation is what carves out reality, what makes an observation real enough to count? What's the difference between just a fleeting possibility and a solid concrete fact? Well, HAFF says it's not some kind of magic. It's a physical process, and it follows a very specific recipe. For something to become a real, observable fact, it has to check 3 boxes. First, interaction. It has to be able to physically connect with its environment. Second, stability. It has to last long enough to actually be recorded before it just fades away. And third, and this one is absolutely key, redundancy. The information about it has to get copied over and over and over again into the environment, creating a sort of public record.
And boom! This solves the measurement problem without any magic. That collapse of quantum possibilities we're always hearing about, it's not some mysterious spooky event. It's just the moment when information about one specific outcome becomes so stable and so redundantly copied that it becomes a permanent, objective fact for everyone. So this framework explains so much by grounding everything in what's observable, but that very strength, that core idea, leads us to one final, mind-bending limit. Where does the explanation itself have to stop? Think about it.
If everything we see, particles, space-time, definite outcomes, if all of that depends on the rules of what is observable, then what explains those rules?
And this is where we hit a logical wall. You can't explain the rules for what makes an explanation possible without using those very same rules. It's like a snake eating its own tail. Any theory about observation has to be, well, observable itself.
Now, what's really cool is that the HAFF framework is totally honest about this limit. It calls it the final cut. And it says this isn't a failure of the theory, it's a core feature. The explanation has to stop right where the conditions for explanation itself begin. It's the ultimate boundary of what science can even describe.
And this leaves us with a really profound final thought. Maybe the deepest kind of understanding isn't about explaining everything. Maybe it's about seeing with perfect clarity the boundaries of what can be explained. Knowing where you have to stop isn't a failure. It's the final and maybe most important piece of the puzzle.